Okay, in this video we're going to look at the notion of a function. So what is a function? Let's first model a function with a machine. So think of the machine here, we're calling it the machine F. And it takes an input. Let's suppose X was its input. Now the machine does something with X, changes it in some manner, and then gives you an output. And here's how we designate the output. This is read f of x, but you see two things here. You see which function you were talking about, and you see inside the parentheses what the input was. Now here's another way to define a function. A function f is a rule which assigns to each member of one set, that's called the domain, exactly one member of another set. We call that the range. So here's an example. F takes the input, squares it, then adds 3. And that perfectly defines the function. It tells you exactly, unambiguously, what happens inside the machine to a generic input. Squares it, then adds 3. But a little better and a little more succinct would be to define this same function with an equation. So here it just tells you what the output is. Okay, so based on a generic input x, here's how you would arrive at the output. So these are the same function. So for example, f of 4 we know would be 4 squared plus 3, or 19. Or f of triangle would be triangle squared plus 3, right? If this was my input triangle, I know to put it right there. Or f of x plus h, that would be x plus h squared plus 3. Here's another way to define a function. So let's look down in the bottom right here. This is the unit circle, so centered at the origin, radius 1. And suppose our input is an angle. Now, defining the angle is this ray here, and where the ray intersects the unit circle, that point, we give names to the coordinates of that point. We actually call the x-coordinate of that point cosine theta, and the y-coordinate sine theta. We'll be seeing this again in the video on trigonometric functions. But you could define a function this way. F of a given angle is the x-coordinate of the corresponding point. So we get the function f of theta is cosine theta. So another way to define a function. There are many ways to do so. Now, another way to, if you will, depict a function is the following. Suppose we take that output and we label it as a y value. Then for each input, x, we get a corresponding y. So here's what we'll say. The graph of a function is a set of all points in the plane of the form x, comma, f of x. So namely where the y-coordinate is actually the corresponding output value. So all points of the form input, output. So over here on the graph, you see I have a value of x, and then a height because that's a y value, f of x. So this point I know would be on the graph of f. And if you consider all such points, it would be some curve. So again, any point on the graph would be of the form input, output. Any point off the graph would not be of that form. So, for example, I'm going to ask you a question. Which point is on the graph of f of x equals square root of 3x minus 2? 2, 6, or 4 square root of 10. One of those is on the graph, one of them is not. Now, we don't have the benefit of the graph. We're not even considering what the graph looks like. But just analytically, which of these is on the graph and which is not? I'll give you take just a moment, pause the video, and see if you get it right. Okay, we're back. If you said 2, 6 is not on the graph, then you were right, because when I plug 2 into the function, I'm going to get the square root of 4, right? 3 times 2 is 6, minus 2 is 4, and that's 2, which that is not 6. So this point is not of the form input, output for this function f. And if you said yes for this one, you were correct. Yes, f of 4 is the square root of 10, right? When you plug 4 in here, 3 times 4 is 12, minus 2 is 10, square root of 10. All right, so that's the basics of functions.